So this is kind of the start of the end of our new content for spring of 2021. We are taking a look at section 31-1, which is area of parallelograms. Now, normally we would have done a whole big chapter on parallelograms. Unfortunately, we don't have time for that, so we're going to just kind of learn about what they are today, understand the concept of area, and learn how to calculate it. So let's start off with the concept of a parallelogram. So a parallelogram, it's kind of fun to write, lots of little loopy L's. Parallelogram is a very specific figure or shape. Do you guys remember what a parallelogram is? Do you know how many sides a parallelogram has? I saw some fingers, and thank you, it wasn't just one, because that wouldn't have been nice. A parallelogram is actually a specific type of quadrilateral. So when we call it a quadrilateral, that means that it has 4 sides. Now, what's very special about a parallelogram is that it's going to have 2 sets of parallel sides. And remember those 2 little slanty parallel lines? That's our symbol for the word parallel. So when I think of a parallelogram, I always think of a rectangle, like a box, but on a slant. So when we sketch a parallelogram, this is a pretty typical looking parallelogram for students and teachers to draw. Now, what's special about these parallelograms is when we think about these sides, notice how I'm going to slip in an arrow on the top and an arrow on the bottom. It means that the top and the bottom are parallel to each other. On the left-hand side, I'm going to do 2 little arrowheads, and the same thing as the right-hand side. That means the left and the right are parallel to each other. But what's really cool about a parallelogram is that if we have 2 sets of parallel sides, we also have 2 sets of congruent sides. So the top and the bottom are going to be the same. So you'll notice I'll give them each one little like slash or tick mark. And then the left is going to get 2 and the right is going to get 2. And there are other characteristics about a parallelogram, but for us and our purposes right now, that's what matters most. You guys doing okay? So I want to talk about some other types of parallelograms because they don't always look like this. And you know I could turn my paper and draw that parallelogram any which way I want. But there's other special types of quadrilaterals that also fit the definition of a parallelogram, and they have unique names. So let's draw this guy. Pretend I can draw perfectly because you guys know I can't. And I'm going to put in some marks here so that you know what I'm attempting to draw. You guys are going to notice that this figure, I'm marking it 90 degrees all the way around. And I'm going to put 1 tick mark on the top and 1 on the bottom, and 2 on the left and 2 on the right. So I'm telling you the top and the bottom are the same length. The left and the right, they're their own same length. Do you guys know what we would call this figure? Starts with an R. No guesses? This guy is a rectangle, and it's actually a parallelogram that specifically has 4 right angles. Now the next one I'm going to draw is also a parallelogram, but it's a special parallelogram. And it's starting off looking a lot like a like a rectangle with 4 right angles. But notice how I'm marking all 4 of the sides. All 4 of the sides are the same length, they're congruent. So what do we call something that has all 4 sides the same with 4 right angles? That guy's a square. A square is a special parallelogram. It's a parallelogram that has all 4 sides congruent and 4 right angles. Okay, we're going to do one more. I'm going to put it over here on the side of the square. This one just looks like a square rotated. I can't ever draw it any better than that. But you're going to notice that I'm not going to mark the 4 angles as right angles, but I am going to mark all 4 sides the same. And this guy is what we call a rhombus. That's an S on the end. My pen kind of slipped. And it's also a special parallelogram. Just getting some language tossed out at you right now. Oh, this one. So these symbols right here? No, I was just too lazy to put them on all of the rest. So by defining a rectangle, a square, and a rhombus as a parallelogram, it is implied that these parallel top and bottom, and then the 2 sets of sides, these are also that set of parallels. I just didn't put them in.
Okay, it's like the same thing.
It's the same thing, yes. So what's special about the rectangle is that it has the 90 degrees. The top and the bottom are the same and they're parallel. The left and the right are the same and parallel. Continuing on with the square and the rhombus as well. Does that make sense? Yes. Yes.
If the rhombus is just a turn square, why aren't the angles kind of big?
It's not a turned square. It's just I can't draw it unless it looks like a turned square. So a rhombus is not necessarily going to have all 4 angles at 90 degrees. It's just every time I draw it, it always looks like all 4 angles are 90 degrees, which is weird. Because when I try to draw something that looks like 90 degrees, it doesn't look like 90 degrees. It's a personal issue. I can't fix it. But at least I kind of answered your question. You can tell I'm laughing at myself right now. Okay, so you guys ready to roll on? Because we haven't really talked about what we're going to do with this stuff. I've got a couple more vocab words I want to address with you. Perimeter and area. I'm going to do these guys side by side. Do you remember what perimeter means? I know you guys have heard that before. How do you find the perimeter of any shape? What do you do? Okay, so I'm going to write it all math fancy. The perimeter is the sum of the sides. And I like to talk about it as the walking distance around the edge of a figure. And one of the big things about perimeter, it has units. So if you're going to walk like around the edge of our high school, you're walking, typically we'd measure that in feet. You're walking a certain number of feet from the starting point to the ending point. And they're kind of in the same spot because you got to go all the way around. So perimeter is going to be measured in units. And I know you're like, what the heck does that mean? That means like feet, centimeters, inches, yards, miles, etc. The perimeter is measured in units. Plain Jane units. Trying to zoom out so you guys can see enough. Area. Now, area is a little bit different. Area is going to depend on the shape that we have. area isn't talking about the outside edge. Area is filling in the space. So when we think about area, we are addressing the space inside that figure. This is a two-dimensional concept. And so when you guys think perimeter, think about if you've ever had to mow a lawn. When we mow our lawn, we take our push mower, because we have a bit of a big yard, and we mow all the way around the edge of the lawn. That is perimeter. But when we cut all the grass everywhere inside that lawn, we use a riding lawnmower because we're lazy and it's a pretty big yard. That's area. So think of perimeter like the outside edge, the fence, and the area is everything else that you have to cover on the inside. So you could think of area as carpet. You could think of perimeter, and I don't know if you guys can all see this, so I'm going to scoot over here, as that trim that goes all the way around the room. You can think of area as the paint we would put on a wall. You would think of perimeter as the tape you put around the edges so it doesn't look icky when you're painting everything. That's the concept and the difference between area and perimeter. So area is going to be units squared. So feet squared, centimeters squared, inches squared, yards squared, miles squared, whatever else we think of, squared. Doing okay so far? Okay. So I'm just about out of room on my paper. So I'm going to turn this in just a second, and we're going to start talking about the area of these parallelograms that we're playing with. Anybody need more time to see this before I turn my page? All right, nobody's fussing at me. Okay, so let's talk about the area of a parallelogram. Now keep in mind, the area of a parallelogram is actually going to be the same as the area of a rectangle, a square, and a rhombus. So by saying parallelogram, I'm being really generic, and I'm covering other specific figures. So the area of a parallelogram, a rectangle, a square, a rhombus is base times height. So we're going to get ready and we're going to practice a few different shapes and areas, and then we're going to be done with these notes pretty quick. So I'm just getting the directions written down for you, and I'm going to draw a couple of shapes and we're going to jump right in. You guys can help me. I need some numbers. On this one, I just need 2 numbers, and you can choose pretty much anything you want. Nothing negative, please. 2 numbers. Shout something out. So I've got a 2 and a 20. Not drawn to scale, right, guys? You know me well. And let's do feet. So this first shape, I need to add maybe some information in here. You guys notice that I marked 90 degrees down here. And when you look at this definitely is not a square. Even though I can't draw well, you know that's not intended to be a square because not all of the sides are the same. So what we have sitting here is implied to be a rectangle. Now, when we talk about base times height, one of the things we need to understand is that the base and the height are perpendicular to each other. They have to meet at 90 degrees. And that goes back to that definition of a height. It's got to drop down or rise up, depending on how you're looking at it, to another length, side, or segment so that they meet at 90 degrees. So when I look at these two lengths, we have a base and a height. And it really doesn't matter how you define them. If you're looking at this, the way that it's drawn, my brain says, oh, the 20 is my base and the 2 is my height. If I were to turn this rectangle, now the 2 is my base and the 20 is my height. And guys, it doesn't matter. Our area will be 2 times 20, which is 40. Base times height, height times base, multiply those suckers. But then go back, find your units, and write feet squared. This guy is done. That's not that bad. That's really quite nice. Not all of our stuff between now and the end of the school year will be that pleasant, but it's a Monday. Let's start off nice with this. You guys good? Let's do another one. So check out how I'm marking this one, even though you know I can't draw. Take note that all 4 sides are implied to be the same, and I've got a right angle. Okay. So this one's a square. For a square, I don't need 2 numbers, I only need 1. Would someone shout out a number for me? 4. So as soon as I label that one side of 4, they're all 4. And let's go meters. 4 meters. Okay? So the area of this, even though I've only been given one side, well, if that side is 4, all the sides are 4. Base times height, we're looking at 16 meters squared. In fact, for a square, it's just one side times itself. It's side squared. Kind of cool. Any issues on that guy? Okay. So we are going to draw a parallelogram. Ourselves a nice, good slant. Now I'm going to mark this so that you know that the left and the right are congruent, the top and the bottom are congruent. Okay. Now on this guy, I'm actually going to create the numbers for you because I want certain things to happen. So I'm going to mark the top as 12 inches. And I'm going to mark the left as 6. Ooh, do I want to do that? Don't mark the left as 6 inches. I lied. Scribble that guy out. I'm going to change my mind on that. On the outside, I want you guys to draw me a dashy line segment. That dashy line segment is not actually part of our parallelogram. It's sitting on the outside. And notice what I'm going to do at the bottom. I'm going to put in a little right angle. And I'm going to connect it to the parallelogram with dashes. With a parallelogram, we can't just use the sides. We really have to think about base times height. I want you guys to mark this as 5 inches. That up and down vertical dashed line. This 5 inches is our height. We know that's the height because it's perpendicular to where the base is if we extend the base. Really important that we recognize base and height have to be perpendicular to each other. Now, with this 5 inches, can't we agree that that is really truly the height of our parallelogram? I just drew it on the outside. From the top side that's 12 and the bottom side that's 12, it's a height of 5 inches. Sometimes the height is drawn on the outside. Sometimes the height is drawn on the inside. It doesn't matter. As long as that height is perpendicular to the location of where the base is, you guys are good to go. So keep that in mind. Sometimes it's outside, sometimes it's inside. So the area of this parallelogram is going to be 12 times 5. That's 60 inches squared. Do you guys have any questions on area of basically rectangle, squares, parallelograms? I know I didn't draw a rhombus. It's the same thing as a parallelogram and it looks like a square. It'll work the same way. You guys good? Do you have any questions? Is this insanely easy and you've done all of this before? Notice I stopped my recording. Good. You guys need a little bit of easy in your life at this point, right? Let's do a little bit of easy. The worksheet that I have is 30 questions long. You don't need to do this 30 times in order to understand it, right? Do you even need to do it 15 times? I don't think so. Here's what I'm thinking. I'm thinking, let's do 1 through 13 odd and stop. Okay, so give me one sec. I am going to get this guy up and running and we'll put it in Google Classroom for you.